Good morning, class. How are you these days? It's good to know that you are all fine. And with that, I want you to stand up and Miss Tilfalie, can you lead the prayer? So now let's check your attendance. If you're here, can you please say present? If you are inside my room, I want you to remember these three things. First, be quiet, listen attentively, and participate. Easy, right? Moving on, our lesson for today is about the evidence of plate movements, which is, to be specific, magnetic reversal. So the lesson objectives are, for the lesson objectives, so at the end of the session, you are expected to describe what is magnetic reversal, evaluate how magnetic reversal can be used as evidence for the seafloor spreading theory, and lastly, outline a seafloor magnetic striping. Before we proceed to the main topic, I want you to pause and think about this question. Does the compass always point north? Why or why not? You can raise your right hand if you have any ideas to share. Your participation is highly recommended. All ideas are valid and right. Does the compass always point north? To answer this question, while the compass is a great tool for navigation, it does not always point north. There are times that it points south. It is not the same as the north magnetic pole of the Earth or the true north or the geographical north pole. When it comes to magnet, we all know that opposite poles attract and same poles repel. So that's why the north magnetic pole of the Earth is attracted to the south pole of the Earth, and the south magnetic pole of the Earth is attracted to the north pole of the Earth. So thank you for your participations. So the first row, can you go in front and get a piece of bond paper? And with that, I want you to arrange the ages of the rock from the newest to the oldest. After you arrange that, you can paste it here in the blackboard. And then, after that, you can go back your seat. Thank you for your participation. So now that the pictures are arranged, what can you observe? Yes, you can see a barcode or a serial code. Where do you think you mostly see it? Yes, in a manufactured products or goods. You can see here is the barcode or the stripes, wherein that stripes, the black and white stripes, represent the surface of the Earth. The black stripes represent the normal polarity of the Earth, and the white stripes represent the reverse polarity of the Earth. The black stripes, which is the normal polarity, indicates that the north magnetic pole of the Earth is found in the North Pole or the North geographical of the Earth. While in reverse polarity, the north magnetic pole of the Earth is now found at the North geographic of the Earth or the North Pole of the Earth. To understand more about magnetic striping or magnetic stripe, let's explore and do this activity. So what do you think is the connection of this to our topic? So now, let's move on and explore about the magnetic reversal. I want you to group yourself into 4 and start counting from here to the back. You can now go and find your group mates, settle down, and then answer the activity entitled Seafloor Magnetic Stripe Plotting Exercises. Just follow the procedure. Make sure that everyone is participating. Brainstorm about the activity and answer the guide questions, and then assign one of your group mates to present the activity about your findings, observations, and answer about the guide questions. The finished activity would look like this. So now that you successfully answered the activity, I want you to answer this question. What do you think is the magnetic reversal, and how can magnetic reversal be used as evidence to the seafloor spreading theory? Before we go on with this topic, I want you to familiarize the following terms. First, the magnetic reversal, which is the process by which the North Pole is transformed into South Pole and the South Pole becomes a North Pole. Then the magnetic striping, which allow the scientists to understand the ages and rate of movement of the materials from the mid-oceanic ridge. In our past lesson in plate tectonics, we found out that there is a convection current beneath the Earth's surface. That convection current consists of molten rocks and magnetic minerals that can be formed into magnet. So ano ngayon kung may umiikot na ganun sa Earth? Well, isa yan sa tinitingnan na evidences ng mga scientists kung bakit may magnetic field sa Earth. We all know that our Earth has its own North Magnetic Pole and South Magnetic Pole just like the magnet. Dahil doon, nagagamit natin ito ngayon para mag-navigate ng isang location, just like for example, the compass. In fact, kapag tinali mo ang isang magnet sa isang string at hinayaan mo itong lumambitin, kusa itong gagalaw sa direksyon na walang bar magnet at yung direction na walang bar magnet, ibig sabihin nun, yun ang South Magnetic Pole ng Earth. Tingnan natin ngayon itong bar magnet na ito na kusang gumagalaw at humaharap sa orientation ng compass. So bakit gumagalaw at kusang humaharap sa orientation ng compass ang bar magnet? As I've said a while ago, our Earth has its own magnetic pole. And just like the bar magnet, we all know that opposite poles attract and the same poles repel. That means the south pole of the bar magnet is attracted to the north pole of the Earth, and the north pole of the bar magnet is attracted to the south pole of the Earth. That's why the compass is moving on its own in order to align to the Earth's magnetic field. So now that you understand our topic about magnet and magnetic field, let's move on to the seafloor spreading theory and the magnetic stripes. So unang tanong, saan ba nanggagaling ang panibagong lupa sa Earth? Well, yes, obviously, sa ilalim ng Earth, this is the liquid molten rocks inside the Earth's mantle. Meron ditong convection current na nagkakos para umangat yung liquid molten rocks at pag nasa Earth's crust na siya, lumalamig ito at tumitigas. So, anong kinalaman nito sa magnet? Alam natin na kapag liquid pa ang isang bagay, malaya itong nakakagalaw. Gaya ng napanood natin sa video kanina, yung magnet, kapag nakapatong siya sa liquid, malaya siyang nakakagalaw at hindi niya ito magagalaw sa isang solid na surface. Since liquid ang napapatungan ng magnet kanina, malaya siyang nakakagalaw at tumatapat siya sa orientation ng magnetic field ng Earth. So, ibig sabihin, sa seafloor spreading, kung saan nagsisimula ang isang bagay bilang isang liquid bago sila maging solid sa crust, mayroon na yung laman na magnetic materials sa loob. So since nasa liquid siya, malaya siyang nakakagalaw at kapag gumalaw sila, ay tumatapat sila sa orientation ng Earth. For example, ang North tatapat sa South Magnetic Pole ng Earth at ang South ay tatapat sa North Magnetic Pole ng Earth, depending on the polarity of the Earth that time. So that means, lahat ng bakal na bato na may magnetic property sa loob ng lava ay nag-orient na sila sa magnetic field ng Earth. Nangyayari yan habang liquid pa sila at kapag nag-solidify na sila, yung orientation na yan ay magiging fixed position nila at hindi na mababago pa. Dito na pumapasok ang magnetic striping. So bakit may stripe sa surface ng Earth? This is because the Earth has two polarities, the normal polarity and the reverse polarity. Ang normal polarity ng Earth ay nasa sa taas, ang South Magnetic Pole, at nasa baba, ang North Magnetic Pole. Kung nagtataka kayo kung bakit baliktad, this is because originally, nasa baba talaga ang North Magnetic Pole ng Earth. Every 100 or 1,000 of years, bumabaliktad ang polarity ng Earth kung saan ang North Magnetic Field ay nasa North Pole na ng Earth. Kaya kapag nagkakaroon ng seafloor spreading, sinasabay nito kung ano ang polarity ng Earth that time. Kaya may layer na may normal polarity at may layer na reverse polarity. Yan ang tinatawag natin ngayon na magnetic striping. Sa magnetic striping, nalalaman natin kung gaano nakatagal ang lupa o bato sa isang area at nalalaman natin kung kailan ulit nangyari ang magnetic reversal. Because of this, nalalaman natin kung gaano katagal ang magnetic reversal, and that magnetic reversal supported the theory of Alfred Wegener about the continental drift theory. So now that you understand our topic about magnetic reversal, magnetic striping, and how can magnetic reversal be used as evidence for the seafloor spreading theory, so now I want you to visit this link from the poll everywhere and answer the short quiz. I will give you 5 minutes to finish the quiz. So now the time is up. So for your assignment, I want you to finish this activity entitled Pangaea Ultima. I want you to find out how does the climate change relates to the movement of the continent. Using the map below that indicates the current location of the continents, if you can speed up 100 million years from now and predict the location of that continents, will they continue to merge into one supercontinent or will they continue to move farther away from each other? Using your coloring materials in a bond paper, I want you to draw your prediction. That's all for today's session, but before you leave this room, I want you to clean and rearrange the chairs as clean and as organized before you enter this room. And please take care as you walk your way home. Thank you.